So today we'll continue on trigonometry, and we'll be talking about the Pythagorean identities. So Pythagorean as in Pythagorean theorem, and identities as in like properties that we can use. So the first identity we actually talked a bit about already last time in the last video about unit circles, lesson 2. So it's basically like sine theta squared plus, so maybe write the theta is kind of weird, sine theta squared plus cosine theta squared is 1. Like no matter what theta is, like no one cares what theta is, as long as theta is an angle, like is a radian measure or a degree measure, this thing should be 1. Well, why is this true though? Like, well, this is actually just back to the unit circle thing. Like if we draw a unit circle, we know that a unit circle's basic definition is that it has a radius of 1. So this means that if I wanted to find like the sine and cosine of any angle, say this angle over here, theta, then I just wanted to find the x and y values of this point. Like the x value would be cosine theta, right? And the y values would be sine theta. So this means that, and I can also draw a right triangle down here to find the values more quickly. So using this right triangle, I know that basically the x coordinate, which is cosine theta, is this thing. The y coordinate, which is my sine theta, is actually this thing. So these two lines actually are the legs of the right triangle, and this is the hypotenuse. Now what's the hypotenuse? The hypotenuse starts from the center and stretches all the way to the end of this unit circle, and it's the radius. It's just 1. So according to the Pythagorean theorem, which is why this is called the Pythagorean identity, this thing is true. Okay, so another theorem we can derive from this is that if we just divide both sides of this theorem by, say, let's try dividing it by cosine theta. If we divide this by cosine theta, we have sine theta squared over, okay, let's try and divide this by cosine theta squared. Plus, this is just going to be 1, because cosine theta squared divided by itself is just 1. And this is going to be 1 over cosine theta squared. Now, this looks kind of weird, but we know that sine theta over cosine theta is tangent theta. So this is just tangent theta squared. Plus 1 equals, well, 1 over cosine theta is secant theta. Like secant theta, right? So what this means is that this can be written as secant theta squared. So yeah, so that's the second Pythagorean identity. So let me just underline these in blue. And then basically what this means is that we can also try and derive a third identity, which is that when you divide both sides of this first Pythagorean theorem, Pythagorean identity, by sine theta squared, we have 1 plus cosine theta squared over sine theta squared equals 1 over cosine theta squared. 1 over sine theta squared. So what this means is we have 1 plus, this thing is like the reciprocal of tangent, and so this is just 1 over tangent theta squared. And this side, 1 over sine theta squared, is just going to be, well, cosine. The reciprocal of cosine is secant, right? The reciprocal of sine is therefore cosecant. So cosecant, so it's CSC. Cosecant theta squared. And we also know that 1 over tan theta squared is just cotangent theta squared. So this is the third Pythagorean theorem identity. So there's these 3 identities. And next time I think we'll talk about the law of sines and law of cosines, IDK. Bye.